And I'm assuming I'll be able to share my screen, right? Okay, so before we get to the talk, I just wanted to introduce myself. So I'm Matt Sherburne. I am in the Material Science and Engineering Department, and I am, I guess, the director or lead or main contact for the MEng program. So that goes from everything to being the admissions committee for the MEng program, and I'm the co-chair for the graduate admissions for the Department of Material Science, to helping you select your courses, right? And then hopefully we'll be fully in person and able to have, right? And so I've held career fairs that are focused on helping you as MEng students get jobs. I've written letters of recommendation for MEng students, and let's see, administering your your exit exam. So I really am the one-stop shop for all things for MEng. And so if you have any questions, you should absolutely feel free to reach out to me. And I am happy to answer any questions. I also serve, there's one person from each department that serves on the Fung Institute MEng Leadership Committee. And so I'm that person. So I help craft and shape the MEng program. And so there you have it. For better or worse, you're going to be stuck with me if you come to Berkeley. So I have a short presentation, right? I'm not going to do something exceptionally long. I think it's better for you to be able to ask questions. And so let's see if I can share my screen. Okay, and let's see if this came up. So do you see the slideshow or my screen?
The slideshow, Matt, we're good.
Okay, I did that right for a change. Okay, so welcome to our orientation. Like I said, I will try and keep it short and sweet, give you a bit of history. It's kind of a new type of orientation, right? As you're all familiar with, the last year has made many changes to how we run things. And so we're unfortunately stuck with a virtual orientation. And I am sure there are going to be questions that come up after this. And I'm sure there are going to be aspects that I might not cover fully that you would like to cover. And if we were in person, we could have a conversation about them. Feel free to ask them now. Feel free to reach out and contact us later. So the people in the department, right? So Daryl Sean is the chair of the department. So I report to him on Masters of Engineering events and changes and whatnot. There's me. You should certainly feel free to email me. This is my new college number because I also am director of international partnerships for the College of Engineering. So I've got a new phone number. I've got Line and WhatsApp already set up, and WeChat was giving me some difficulties in setting up. So hopefully by the end of the week, I'll have WeChat set up. So, right, the idea is I'm available to you. If you have questions after this, you should feel free to reach out to me. And then, of course, Ariana, who is the one-stop shop for all questions about, your matriculation, and she helps you navigate the bureaucracy that is Berkeley. And in many respects, she will navigate the bureaucracy for you. So the other thing is she will correct everything that I tell you that's wrong. So she's an incredible resource. And so in the department, you really have Ariana and I that are here to help you get out of the program, or at least the material science part of the program, what you want to get out and what would best serve you. Let me make, there we go. Oh, of course it doesn't. Okay, so just a quick bit of history, right? Initially, there were 3 technical colleges at the university. College of Mechanics, which really was what we would call mechanical engineering now, and the College of Mining. Well, the College of Mining ultimately became, right, material science. And so we've really been one of the founding colleges at the time, now departments, since we're in the College of Engineering, for the university. And so we've gone from mining to mining and metallurgy to material science and mineral engineering to material science and metallurgy, and finally just material science and engineering. So we've had multiple names over the 150 plus years that we've been around. But it's always been with this kind of material focus. So this is what the university looked like back then. And if you come and get to be here on campus, this building to the left is South Hall. It's one of the original buildings on campus, and it's still here. After those 2 buildings, Hearst Mining Building was built, and it was named after George Hearst. And so the Hearst family made their money in mining. If you look up the Comstock in Nevada, this was the world's richest silver mine. And so the Hearst family was very well known in mining throughout the Western US. And in fact, on the back corner of the building, we have a mine shaft. So into the hillside, when the students would push the rail carts into the mine shaft and actually mine. So the Hearst family was very good to the university, built dorms, and there's Hearst Avenue, right? Their names are all over campus in the Berkeley area. And Phoebe Hearst was the first female regent in the UC history. And so she did a lot to shape the campus in general. So then Hearst Mining Building, right, 1902, the cornerstone was laid. 5 years later, the building was up and running. Then from the mid 1990s to early 2000s, the building was retrofitted and formally opened in 2002. And so the building now sits on base isolation units and has a little moat around it. And so if in the case of an earthquake, it literally is possibly the safest building in the Bay Area, or at least the safest building on campus to be in, as it's designed specifically to handle earthquakes. And it's a National Historic registered building. And this is the lobby. So you walk into the front, through the front doors that you just saw, up the stairs into the doors, you walk into this lobby, and the bottom doors that you're looking at is 210 Hearst Mining, and that's our office, our main office. So if you walked in there and you took a left turn, there's Ariana's office. And so we will be in person next fall. All right. The UC president has announced this, that all UCs will be in person. And so you would be able to walk in there and say hi to Ariana and get help you need. So the department, right, we're well ranked at, you know, I take the rankings with a grain of salt. I think it's more impressive that we have, I think, 7 faculty members that are ranked as high as, I think, 106 to in the top 1,000 of research publications in the world, regardless of fields. And so that includes medicine, which tends to take up the top 5 to 10 rankings. But then we are, as far as research output, and, you know, rankings in research output, we are probably the highest out there. But, you know, on a grand scale, we do try and improve, and so we're always trying to get better in the rankings. Our program is small. The MEng program is kept specifically small, and I'll talk to you about why that is. But we have roughly the same number of undergrads as PhD students. Our undergrads can do a BS/MS. And then the Masters of Engineering, really, we try and keep this at about 20 students. We would have been about 20 students. We're 14 right now. We had, and I haven't seen all the names on the call, but we had a number of students that deferred from last year, right? We admitted them. COVID happens. They didn't want to try and come. And so, well, they couldn't come, and then it wasn't in person. So they deferred. And so my guess is we might be a little over 20 this year, but not much. And this is intentional, right? We want to be able to have you have a personal experience, and you be able to really just stop by my office if you need to discuss something and figure something out. And if we run a program that's, you know, if we kind of exceed 30, then it gets tough, right? If we get to 50, I can't really just have an open door policy. And so my guess is that our number of students next year will be maybe just a little over 20 when those that deferred end up enrolling. But that's about the size of the cohort you'll come in with. So there's, you know, we're a very research active department. You as an MEng student would have to do a capstone. We have had MEng students that have done research in addition to the classwork and the capstone project. And so that is an option. We have lots of research funding. On average, faculty are about $1 million a year of expenditures on research. We currently have 18 faculty. We have a new faculty member joining us this coming summer. And we might have a second faculty member joining us. We're hoping to recruit somebody. We've got in the space of 3D printing and additive manufacturing. So we're looking at expanding into that area, and hopefully we'll have a new faculty member for you to interact with next year. So the thing is, campus is big, right? We maybe not geographically, but we have overall somewhere around 35,000 students, undergrads and grad students. The materials department is small. So you really get a small school feel from the department, and our classes are taught in Hearst Mining. Our student spaces, which you will get access to the graduate student bay. It really is, despite the fact that it is a large campus, I think as the department, we have a small school feel and a very personal feel. Um, Depending on the capstone projects that you might do, or the research projects, if you wish to do research, you might do, right? We have a number of facilities at LBL. Lawrence Berkeley National Lab is right behind campus. And so like the molecular foundry, Kristen Pershawn, who's a professor in the department, is the director of the molecular foundry. Andy Miner, who's a professor in the department, is the director of the National Center for Electron Microscopy. Right, so we have very strong ties to LBL. So if there turns out if there is something interesting up there, we probably know somebody that we can send an email to and make an introduction. The other reason to point this out is I was just on a call last night with Professor Asta in the department, who happens to be the director of the Material Science Division at LBL. And we're looking into starting a effort that is directed at the MEng program in energy storage. And we're trying to figure out how we can get capstones from LBL that are very research related, and yet have this industry flavor. And so hopefully by the fall, if you were to show up on campus, we would have a number of new capstones in energy storage available to you. That's something we're working on, and those would take place up at LBL. And so you would go up to LBL and do your research and capstone activities up there. So we have a number of project or facilities on campus. And so over here on the right, you see the microscope with the two folks sitting at it. The one in blue is Professor Andy Miner. The one in the short sleeve white shirt is Professor Peter Hoseman, who's the chair of nuclear engineering. And so why am I showing this? Well, Peter and I run 3D printing capstone projects. And so at this facility, we have SEMs and these types of things on campus. And we get you access as students to these facilities. And so unfortunately this year we haven't been able to do it because of COVID, but last year, right, our students were in there using the SEMs and using the different facilities to characterize the different processing paths and properties of the materials that were being printed. And so the goal is to get you skills that are marketable in the real world. Or if you want to continue your graduate education, that are marketable to a different graduate group. And so we have these facilities, and depending on the capstone project, right, they will be available to you, and we will get you access to those that you need access to make progress. Okay, so curriculum, right, and program. You have probably seen something like this. I've written up a 2-page kind of flyer that walks you through everything. And if you come here, right, we'll meet again, and we'll meet in person, and I will email you the flyer, and I will give it to you in person, and we'll walk through it. But the idea is, right, you have the leadership courses, but you have the material science courses. And you see I have 4 material science courses listed. MSE 200A, then 200XX, 200XX, 200XX in the spring. So nominally, MSE 200A is required. I'll talk a little bit more about that. But this is what a typical fall spring look like? It is a busy program. We have had, like I've said, we've got MEng students that do research. We've had MEng students involved in other academic endeavors outside of the program. And in fact, yesterday I emailed Mark, who was an MEng student, and accepted Mark into my PhD group. So he'll start in the fall as my student. And he worked for me as an MEng student. So there are other opportunities. Know that it's busy. You're going to be busy, but if you budget your time appropriately, you can do other things that are of interest to you. So we try, and we're in the process of planning out further. Right now, we're only out to fall 21. We have new faculty joining, so we're trying to figure out what classes they're going to teach. And so by the time you show up, we will have, fall 21 and spring 2022 fully planned out for you. But let's just look at fall. So MSE 200A is offered in the fall every year. And material science is interesting in the fact that at the graduate level, we get multiple students from chemistry, chemical engineering, physics, biology, that want to take and transition more into engineering. And it turns out material science is the logical transition. And so 200A is really a course that's designed, it's a survey of material science for a graduate student, and it's designed to get you to understand what material science is, understand the fundamental tenets of material science. And really the idea is that if you go out to Apple is going to expect you to understand a little bit about many different things when you interview with them, such as a structure property relationships that is so key to material science. Well, MSE 200 is the place you get that in our curriculum. If you come from an MSE background, you can opt out of 200A because you've been exposed to this. 201A is Professor Sater's thermodynamics class. We will probably be offering 201B with the new faculty member, which is really a statistical mechanics class. 118-208 is Professor Healy's biomaterials, bio-inspired materials class. 211, traditionally taught by Professor Govinji, is a mechanics class. So mechanical properties and the foundations of how you describe mechanical properties. 215 is taught by me. This is our computational material science class. 218 is a new class. This will be the second time it's taught. This is Jay Yao, and he's an expert in optical properties. And so this is a new course we developed, well, that G developed, that is on optical properties of material. Professor Wu, 223, is semiconducting materials. 225 is Professor Al-Balushi. This is thin film growth, and so how you grow materials. 250 is Professor Messersmith. This is a nano bio-inspired biomedicine course. 251 is Professor Zhu. She teaches this is a polymers and surfaces and interfaces type course. And then in the spring, once we have the final list, right, you'll see another whole set of classes that will be offered. And, just if we go back to kind of what's being taught now or what's been taught in the past. So I've taught 202, which is kind of advanced bonding and crystal structure, a little bit of towards physics. So we do group theory and it's much more physics driven. Professor Miner teaches 204, which is characterization, TEM, SEM, X-ray diffraction, all of that type of material. 205 is taught by Professor Ramesh, and these are defects in materials. So you understand defects, the formation of defects, and how they affect material properties. Professor Ritchie teaches 212, which is our fracture, fatigue, and failure of materials class. 214 is another structural mechanical properties type class. 216 is another bio-inspired class by Professor Healy. And 217 is Professor Martin's ceramics functional materials. So ferroelectric, pyroelectric, right? Multiferroic materials that he teaches. And then 241 is Professor Scott's TEM lab. So if you like characterization of materials, 241 is a whole semester of nothing but TEM, where you actually get to spend time on the TEM using the TEM transmission electron microscope, characterizing materials. 242, Professor Eger's, it's also a characterization class, but it looks at non-TEM, SEM type characterization of materials. And then 260 is Professor Salmeron's surface science class. So there may be some changes, but predominantly everything up to from 202 to 241 is taught every spring. And so this gives you an idea of what will be taught. If you have a strong material science background, you can opt out of 200A, okay? What this entails is essentially you email me and say, hey, I got my undergraduate degree at Carnegie Mellon, or I got my undergraduate degree at NTU in Singapore in material science, right? Or we've had students say from Fudan University who got their undergraduate degree in materials physics, right? So I will work with you, right? If you have a strong undergraduate degree, you can opt out of 200A. And just the process is I will email Professor Ritchie, who's the chair of our committee in charge of these things. And the committee will decide if I will make the recommendation and spell out how I think you're qualified to opt out of 200A, and the committee will make the final decision, which I have not had a student rejected who has asked to opt out, and I have said yes to opting out of. The advantage of taking 200A, particularly if you do not have a strong background in material science, is that the program has a comprehensive exam. The comprehensive exam is based on the content in 200A. Now, if you opt out of 200A, I will get you, and I've got PDF versions of the readers and of the old exams and midterms and finals and all of that for 200A. Professor Morris shares this with the class. If you opt out of 200A, I will share all of that material with you so you can see what is likely to be on the comprehensive exam. I also email out a guide for the comprehensive exam. right? Material science is a rather broad area. And so I will give you kind of the 4 topic areas that the exam will be on, say mechanical properties, thermodynamics and phase diagrams, and that type of breakdown. It's 20 questions, it's multiple choice, short answer, 60% is a passing grade. We've never had somebody, you get 2 chances at the comprehensive exam. We've never had somebody that hasn't passed it by the second chance. And we've only had 2 people have to take the second one, right? So with the guide that I send you out and with your background and or in 200A or from your undergrad, with a little bit of studying, you can pass the exam. Capstones. We offer MSE capstones. So I've run one with, unfortunately, I won't be running it next year, with Eris Composites. They're a company here in Berkeley. They're not going to run it simply because COVID and they don't know where they're going to be. And so they don't want to sign up. And so students have traditionally gone down to the facilities of Eris Composites and done their work at Eris. And Eris just doesn't know what the status is going to be, so they weren't willing to sign up. But I will compile a list. It looks like I've reached out to all the faculty members, and so be able to send you a list of our capstones that we offer as a department. Now, it's not only the MSE capstones that you can take. You can opt out of an MSE capstone. You can take one offered by, say, mechanical engineering. The only caveat is, right, you have to tell me what capstone you're going to do. And I know most of the capstones, or I certainly know the advisors. And so I can look at the capstone and make sure there's sufficient materials content, right? You're getting a degree in material science. And so your capstone has to have a real materials element to it. And that's all I look for, right? We've had, again, material science is fundamentally interdisciplinary. So if you want to take a capstone from bioengineering, odds are it will have enough materials component to it. If you want to take a capstone in mechanical, right, we can work, and I've worked with the faculty in these other departments. So if there's something that really strikes your fancy and you're really interested in, and it's in another department, talk to me and we should be able to make that happen, right? We should be able to work and figure out if there's enough materials content in it. And I'm assuming that you applied to a materials program, so you're actually interested in materials and not something else. And again, so then we'll just get approval, and anything I have approved has not been turned down by the AAC. If you want, right, you can stay for a 3rd semester. And, you know, I just had a student tell me he thought he was going to stay for the 3rd semester and now just sent me an email last week. Hey, I got a job. I'm not staying for the 3rd semester. Fine, right? Again, this is one of the advantages of having a small program. We'll work with you. If you're here and you think you might want to stay with the 3rd semester, just come talk to me, right? The idea is to, within the framework that the MEng program provides, is to provide you with as much flexibility as I possibly can. And so, yeah, with that, thank you. And I will go ahead and stop and take any questions and I think we have several current or former students here, so they may be better at answering some of your questions, but yeah, if there are questions, please.
Hi, Professor. I had a question about the comprehensive exam and like 200A. So
Yeah.
since like it's based on 200A, would you say that it's better to take it even if we do have a material science background, just so we can like get that information throughout the semester?
So, I mean, obviously, if you do that, it does make the exam a little bit easier. So, what I will tend to do is I tend to recommend that you sit in on like the first week or two of 200A, see where your knowledge, right? Because Professor Morris will lay out the course. I will send the readers to you. You will probably have to remind me because it's the beginning of the semester and crazy, but I will send the readers to you. And as you listen to the lecture and then you thumb through, flip through the readers, if the content, and this is, students will go, oh, wow, there's a lot of content in here I hadn't seen as an undergrad. I'll go ahead and stay in 200A. Or people will go, oh yeah, I've seen all of this content. I had a class on electronic properties. I had a class on mechanical properties. Right? And so if you went through a traditional materials curriculum, you listened to the first week or two of lecture, and then you look through the reader and you're like, okay, I'm all right. Right? That's how I suggest going about making this decision.
Okay, thank you.
Yeah.
I guess kind of in relation to choosing classes in general, are we able to sit in maybe the first week or so
Absolutely.
in different classes and then just like pick afterwards?
Absolutely. That's one of the nice things. I don't know how your undergraduate institution works, but every undergraduate institution I have taught at, or was a student at, it was tough for undergrads to get classes.
Mm-hmm.
The graduate classes aren't so tough to get. The one caveat to that might be 241 or these classes that are really heavy lab classes. Those you have to register early for because the space is limited. But like with 215, if I have 20 people or fewer in there, it's a very personal class. But once I get to, 30 students, it really doesn't matter whether I have 30 or 60 students. So last time I taught 215, we ended up having to move to a larger classroom because, the classroom I was in held like 50 and we had like 65 students in it. So yeah, I have not seen, other than a few of the specialized courses, and I will say Professor Messersmith's 250 also tends to be small because that's a very hands-on course, and the way he teaches it is there's lots and lots of interactions with Professor Messersmith. But yeah, on average, you should feel free to sit in on all the courses. I will advise you on those that you should just register for. And then if you absolutely don't want it, you can drop it and somebody else will take your slot. Okay. So yeah, so you're going to be, so there was a message in the chat, mechanical engineering major, but I was interested in material science. Yeah, so there are a number of projects and capstones that cross the disciplines. I would say mine with Peter Hoseman certainly does. I think Capstones offered that. Yeah, Tarek Zodi in mechanical engineering, he's got a number that are materials related. Hayden Taylor. So from that side, from a capstone side, there's certainly materials related projects that would fulfill the mechanical side. So my 3D printing project this semester, I have 5 students on. 2 of them are mechanical, 3 of them are materials. So thinking back, I don't think I've had a semester where I have not had mechanical engineering students in my capstone teams. As far as talking about research projects, if you're interested in research, right, find faculty that are working in that area and, send them an email, but the best way is to go knock on the door. Find out when their office hour is and just go see them and, talk to them. I've had, well, like I said, Mark, who will be joining as a PhD student in the fall, was an MEng student and is joining my group for his PhD. Rupung, who just finished his PhD, was an MEng student and ended up getting admitted into Professor Miner's group for his PhD. There have been a number of MEng students that one off the top of my head, because I wrote him a letter of recommendation, went to UCLA. Another one I wrote a letter of recommendation for, she's at Northwestern for her PhD. So it's not the norm. I don't want you to leave here, this meeting, thinking that 90% of our MEng students go on to PhDs. But yeah, I would say every year we probably have, out of 20, we have 2 to 4 that go on to further graduate study. I had one, AJ, he ended up, while he was here, he was working on a machine learning project and worked on a project with me, fell in love with the data science. And so he ended up going and getting another master's in data science. And it turns out that's what he wanted to do. That's even more rare to go get another master's. I think he's the only one I've had that has done that. But yeah, so every year we probably get, somewhere between 2 and 4 out of the cohort of, say, 20 that go on to get a PhD. So it's not uncommon, but it's not the normal path. Any other questions?
Can we email you if we think of any other questions?
Yeah, absolutely.
later
Let
on?
me, you know what? That's a good point. Let me, yeah, I'll throw that up. Yeah, mine's a crappy email, MPSHERB. It's kind of my first 2 initials and some part of my last name. The university assigned me it when I came, and then turns out changing it was a giant pain, and then everybody had it, so now I'm stuck with it. So yeah, you can call me, WhatsApp me, but I will be honest, the best way is to email me. And then if we need, we can set up, if it ends up being very detailed questions, I'm happy to set up a one-on-one Zoom call or something and talk to you. So yeah, absolutely. You should reach out to me, because I am sure there is stuff that I did not cover that I should have covered. I am sure that questions will pop up to you, as you sleep tonight and go, oh, I should have asked this. Right? And so you should absolutely feel free to reach out to me.
Hey, Matt, if there aren't any other questions, do you think it'd be good for either Michael or Chinte or both to share their experience in the
Yeah, so
program?
yeah, that was the next. I was going to ask Michael if he had anything to say, and I will stop sharing my screen and let them weigh in.
Yeah, sure. I mean, yeah, it's Michael here. I can kind of quickly share a little bit about it. Also, kind of my journey, just really quickly. I actually graduated on the MEng program, I think back in 2014, which is kind of a long time ago. I think I just like excited to see how the program has kind of progressed over the past 6 years now. But I think the structure of the program and just what it entails, combination of leadership and cross functional trainings, as well as just core discipline for other courses that Professor Matt just basically kind of outlined, kind of really took me back about some of the courses there. Yeah, I mean, it was great. I think the experiences over there. I think one key thing is definitely about time management, because as you can see, the course load over there, plus all the different stuff that you get offered, it just crazy amount where you want to kind of experience everything. So I think time management is definitely the key there. But otherwise, I think the trainings I had was really beneficial for my careers right now. So I'm really grateful. But that's kind of a short version of what I might take away is. I think one thing is that, yeah, I actually live in an international house when I was there. So, that was a great, very great experiences also, where you interact not just with the MEng program, people, but also from the people over there, who just kind of really, get you exposed to the experiences of the diversity of views and people that you kind of come across, which is really, really been a very great experience for me. So I just want to shout out there for a sec.
Thank you, Michael. How about you, Chinte? Do you want to share anything about your experience in the MEng program?
Yeah, it's been. I graduated from the 2018 cohort, and it's pretty cool to see like how the program has progressed, and with different more options in terms of courses, capstones, and all other resources supports from the department. And I think, yeah, I want to share about my experience. So I think all the incoming students have to um, be care to have to know what they want to get from this program, and to choose their capstone project and wisely, and their courses wisely, to get most out of this program. And for instance, I took a capstone I joined the capstone project, which is we're working on a new electrochromic material synthesis, and it's kind of like a small startup that we were working on, and that's I used that capstone experience to get my first job, and also other courses also helped me to get the skills I need for the job market. So yeah, I think you have to be clear about like what you want to do. Either you want to go like Professor just mentioned, you want to go to further graduate study, or you want to go to the job market. You have to be clear about what you want to get when you choose your capstone project or your courses.
Thank you.
Yeah, thank you both for taking the time and being with us. Jinte, good to see you again. Michael, nice to meet you, since you actually graduated before I came and took over the MEng program.
Yeah, it's, yeah, it's good to be here.
I did have a question, just like following what you two have shared. So when you picked out your classes during the MEng program, did you have a specific industry that you wanted to go into and then just kind of kept that in the back of your head as you were planning your courses?
Yeah, maybe I would just go first. I think my strategy is a little bit different. Because it's a relatively short program, I think, I don't know if they can offer this kind of flexibility. There's the core courses, but also there's technical electives that you can choose. And I basically just chose, there's some core requirement you have to fulfill for a certain number of credits, at least at my time. So I chose to kind of fulfill that quickly in the fall semester, where there's actually just happened to be some courses I'm really interested in. And then for the spring semester, I know that it's going to be crazy with, the end of the capstone project. You look for your next opportunity, whether it's your job or further research on pursuing a PhD or whatnot. So I want to kind of give myself a little bit more time. So that's kind of how I structured it into like front loading about more about the core courses in the fall. But yeah, I was really interested in energy. I was part of the high energy, what's it called again? Energy storage, high energy systems. I think that was the concentration. And my capstone project is actually about energy storage. It was about Flywheel, which is a kind of collaboration with the mechanical engineering department. So that's kind of where I kind of do my focus on. I think the thermodynamics and semiconductor courses, I think is with Professor Wu, if I remember correctly. And those are, I think it's very applicable just, because where we are from the Bay Area, Silicon Valley. So you want to kind of understand more about that. Yeah, that's kind of how I structure about the technical electives of core courses. Just purely about like kind of what's available and what interests me at that point.
Yeah, to me, to be honest, I didn't like have a clear like target or like industry when I just joined MEng program, but I do feel like you have to have a better understanding, or like if you're AMS, the job market, you have to have a better understanding in terms of like what are the skills they need, and try to get those hands-on skills like in your capstone or in like courses, like TEM, SE, and those kind of more hands-on experience is what a lot of positions are looking for. And yeah, I would suggest income students to plan ahead and to really to really like plan ahead and to just get your skills ready.
Yeah, thank you.
I'll just say, I'm happy to meet with each student and, discuss career goals and which classes might fit best into your career goals, right? To help you plan a schedule that makes sense for what you want out of the program.
Yeah, I just want to add on like quickly. I remember, I think back in my time, I think there was only 4 or 5 students. It's from MEng on MSE.
Yeah.
I mean, overall, I imagine just smaller back then too. So I think what Mel was saying about smaller groups and proximity to the faculty members, as well as people that can help you, that was really, I think, beneficial for me as well. So definitely, I think that's a very valuable resources that you should really take advantage of if you have the chance.
Okay, well, if there's no more questions, then I think we're done with the session. I want to thank you guys all for joining us and hope to see you guys all in the fall. Also, feel free to email me if you have any questions, and I'd be happy to answer them for you.
Yeah, thank you, everybody. And specifically, thank you, Michael and Chinte. Really appreciate you taking time out of your schedules to be here with us.
No
Yeah.
problem. Happy to
No
help.
worries.
Thank
All right,
you.
good to see you guys.
Bye-bye.
Thank you. Bye
Take
bye.
care, everyone.